This is the monstrous machine, the Caterpillar 797B. Everything about it is massive. You can tell just by looking at its scale. It's awe-inspiring. This is a groundbreaking design. Its scale is earth-shaking. The truck is over 7 meters tall, 14.5 meters long, and 9 meters wide. It's almost as tall as a two-story building. When fully loaded, it weighs over 650 tons, even heavier than a Boeing 747, with enough power to move mountains. It's equipped with gigantic twin engines, producing more than 3,500 horsepower, which is equivalent to 2 M1 tanks. The engineering behind creating this monstrous machine costs $80,000 a day just in fuel. To build this beast, valued at over $35 million, Michelin manufactures its 5-ton tires in Lexington, South Carolina, along with a 45-ton cargo bed. Now, caroling nay vod, assembly takes place in Canada to put together more than 600 tons of parts. The 797B chassis is the backbone of the truck, a crucial foundation that holds this giant machine together, bearing enormous loads. The chassis is made up of 9 cast sections, measuring 37 feet in length and weighing nearly 28 tons. It all starts with molten iron. Metal is melted in a 45-ton electric arc furnace. Workers fill the furnace with metal scrap, while operators lower 3 highly charged electrodes into the chamber. Once the electrodes make contact with the metal, they create an electric arc that reaches 4,000 degrees Fahrenheit. As the metal heats, it bubbles and melts. The workers use cranes to move an empty 20,000-pound ladle toward the waiting electric arc furnace, guiding it to pour the molten metal into the part mold. The workers place the ladle over the pouring hole. This mold, filled with steel, needs to cool down for a full 36 hours. Once it has cooled, the mold can be removed. The 9 chassis parts of the dump truck are then ready. Workers proceed with ultra-smooth welding. On the last cast segment, workers will machine these surfaces. During the assembly or welding of the truck, these cast surfaces are machined to tightly control the joints and ensure superior welding connections. Workers are placing the chassis pieces into clamps, which are like giant tongs that hold the chassis in place. Each chassis part weighs anywhere from 500 pounds to over 6 tons, making moving them a massive task. The workers have to perform a total of 18 welds, and the enormous Caterpillar chassis begins to take shape. The chassis, which weighs over 30 tons, is extremely durable and can last for more than 20 years. This ensures the durability of the truck's load-bearing capability. Caterpillar's yellow steel has transformed the world. The 797B chassis must be rock solid, or the truck could collapse entirely. Technicians use ultrasonic testing devices to repeatedly inspect the critical seams. This tool emits high-frequency sound waves that pass through special conductive gel, and a connected computer detects and converts the reflected sound waves, producing an image with different colors that reflects the strength of the welds. This system works like a deep scanner, revealing even the slightest flaw. For the 797B, the conditions are stringent. The world's largest tire presents another challenge, standing over 4 meters tall and weighing 5 tons. This tire is as tall as a 1-story building. The rubber used in it is enough to make 500 tires for regular vehicles. These tires are not cheap either. Each one is worth between $350,000 and $700,000. Each Caterpillar 797B dump truck requires 6 tires. There are several key stages in making these monster tires. First, raw rubber enters the plasticizing machine, where it is ground into sticky balls. The sticky balls then go into a mill, where they are pressed into thin rubber sheets. As the rubber passes through the mill, it is flattened. The giant rubber sheets are spread out, sprayed with water to cool and dried. The workers roll up the rubber sheets, which naturally stick together. It takes a total of up to 130 layers of rubber to form the main surface of the tire. Technicians roll these giant rubber pieces into highly confidential molds, where pressure and heat imprint the tread pattern onto the rubber, making these Caterpillar tires the strongest in the world. These monstrous trucks work here with 3,550 horsepower engines. The 21-ton engine is located deep within the belly of the dump truck, giving this massive excavator a low center of gravity, keeping it stable on rough terrain. But to witness the manufacturing of this monstrous diesel-powered drivetrain, in terms of raw power, it equals 7 Ferrari F430 engines. Weighing more than 21 tons, the 24-cylinder engine produces tremendous horsepower. Horsepower measures the engine's maximum output, and the bigger and heavier the vehicle, the more horsepower is needed. To create the unique twin-engine system for the 797B's diesel-powered drivetrain, it will become the largest truck engine in history. This engine operates on principles similar to a regular diesel engine, but the difference lies in its massive size. Here's how it works. Inside the cylinder, a piston connected to the connecting rod compresses the air. This pressure heats the air, forcing the piston downward, which then drives the crankshaft. The crankshaft transfers energy through a set of gears, eventually powering the vehicle. The connecting rod is one of the most critical components of this engine, connecting the piston to the crankshaft. The engine's internal parts are finally installed. Workers hook the engine to a 60-ton remote-controlled crane, and the team carefully guides the 18-ton engine into the space within the truck's chassis. As this giant machine begins to take shape, it has already reached more than 50 tons and is a massive object. It's now ready to be loaded onto a flatbed truck and transported kilometers away to Alberta, Canada for assembly. Caterpillar's designers have equipped the 797B with the ultimate dump bed, measuring nearly 32 feet in length and made of solid steel. The 797B's dump bed is composed of 5 prefabricated parts: the floor, 2 side sections, the front wall, and the top. Welders hook the floor section to the crane and connect it to the other parts, tightening the bolts and welding it together, then hoisting this 15-ton metal plate. As they align the floor with the flatbed truck, they have to be extremely careful to prevent the floor from swaying, or the truck and the plate could both tip over. Workers have already bolted the first side section of the dump bed. The team bolts the floor and sidewalls together. Now it's time for the final front wall. Welders are securing the bolt brackets that connect the front section to the sidewalls. Workers use an impact wrench to bolt the 2 sides together, then spot weld the front section to the sidewalls. The massive 797B dump bed is finally complete. Next in the challenging assembly process is installing the 7-ton transmission. This task requires a heavy-duty crane, and the challenge is ensuring the lifting straps securing the transmission are sturdy. The straps can easily snap if overstretched. Workers have to fit the transmission into a very tight space, which is no easy task. One wrong move could damage other parts of the truck. They must avoid hitting anything else. The team installs the transmission with extreme precision. The next task for the mechanics is to lift the 14-foot-tall, 5-ton tire into position. These massive rubber tires reinforced with steel belts are very different from regular cars, which only use 5 bolts to secure the wheel frame. Here it takes 47 bolts to lock the wheel frame in place. Once the tire is in the correct position, the team uses 4 hydraulic jacks to lower the truck from the assembly line. This monster truck still needs one final crucial part. It heads to the factory for the final stage of assembly, attaching the dump bed. This is a tough challenge. Workers first attach 50-pound hooks to the dump bed. It takes 4 lifting straps and 2 cranes to hoist the 45-ton dump bed into the air. The driver maneuvers the Park 797B under the dump bed. Workers lower the swaying giant dump bed to align it with the 2 pin brackets, and once the bed is in place, the task is complete. First, they insert 2 metal shims between the dump bed and the pin brackets. This prevents lateral sliding during operation. Then they hammer the pins into place. The 797B's engine is fired up, lifting the dump bed. The massive dump truck is perfectly assembled. This giant machine required 6 different factories, over 600 tons of materials, and about 80 days to complete. Finally, this colossal beast is assembled. It can carry 400 tons at a speed of 40 miles per hour. This machine is now ready to head to the mine site, prepared to battle in the vast mining field.